Hello, good evening, my warriors. Welcome to the next session of Current Electricity. Before we begin, I want you to take a guess. Who is the famous personality on the screen? Well, it's an easy one. Come on, you can do this. Can you guess? Who is this famous personality on your screen? Come on, it's an easy guess, I'm pretty sure. Come on, all my warriors, post it up in the chat box. Hello, Rushikesh, PL, Ankit, Raghunesh, Punitali. Welcome, Clay Tsunami, Srinidhi, Logeshwari, Harni, Sagar, Samuel, Chocolate, Lillian. Come on, all my warriors. Kirchhoff? No, it's not Kirchhoff. And I guess Harni got it correct. Yup, that's Wheatstone. His name is Charles Wheatstone. He was an English scientist and he invented many things, many scientific breakthroughs in the 1800s, and today we are going to see a very important concept based on the Wheatstone's setup, and we are also going to see how to measure resistance using Wheatstone's bridge. So welcome aboard with me, Shreyas, your master teacher for physics at Vedantu, going live. Hello everyone, welcome, good evening all my warriors, vanakkam, hola, bonjour. This is Shreyas and I not only teach on this platform but I also teach on the Vedantu's paid platform. So many of you might have seen me over there, and yeah, those of you are very new to this channel, well, I have been teaching for a very long time, don't go by my looks, and almost like a decade, and I have graduated from NIT Nagpur and then I did my research from IIT Bombay. And over the course of my teaching, many of my students have entered into IITs. Some of them have even graduated now and they are doing really well in their well-paying jobs, and many of these students have got really amazing ranks below 50 and below 100. So I really hope these series and my teachings will help you get an amazing rank for you guys next year. So welcome aboard, and if you want to know more about me, definitely can follow me on my Instagram handle. That's Shreyas_Vedantu. Yes, that's my Instagram handle. And before we begin the class, do not forget to smash that like button because it shows your love, your support for me and this channel, because this is a dedicated English medium channel for all of you. So do not forget to also hit the subscribe button so that you do not miss any of the classes that we conduct out there. Hello Vaibhav, hello GK Guru, good evening everyone. Hello Nancy, Neha, Vibesi, Yalini, Akash. Look at that, the crowd is really good. I'm very good, Harish, thank you so much. Ishan, yes, I do remember you. Hello everyone. Welcome, vanakkam. Hello Ankit, hello. My school gave me lots of online assignments and video making and it sucks. PL is very angry with his school. Oh my god. Yes, it's okay. You can remove all your frustration out here. And by the way, I have two surprises for you, or rather two news for you. One of them hopefully should be out by tomorrow, and another one is going to happen on Saturday. Are you guys excited? Can you take some guesses? One of them, I'm in the process of making something and I'm going to show it to you tomorrow. It's a very nice upload that I will be putting up tomorrow, and on Saturday a very special event, very special person is going to come for all of you. All right, so okay, thank you Keshav. Okay, so keep yourself updated, stay tuned, hit the subscribe button in case you have not done it yet so that you do not miss that update. And by the way, this is the schedule for this week out here. So you can see what I'm going to do this entire week. Usually my lectures are at 7:30. We are doing Wheatstones and meter bridge today, and on Thursday 7:30 voltmeter, ammeter and potentiometer. That's very important. And on Wednesday I'm doing addition of vectors, that's for 11th standard kids, subtraction and resolution of vectors, that's happening on Friday, and the special session, like I told you, that's happening on Saturday. And tomorrow morning a very special session for all of you. Yes, all three of us, yeah, we are going to do this challenging and scoring questions for VIEEE examination 2021. So if you are a 12th standard student who is giving the examination this year, so this session is exactly meant for you. And let me also tell you guys, Vedantu has been producing amazing results over the past years. And in fact, this year's results have been even more amazing. If you compare the Vedantu's average with the national average, it's like 6 times, 5 times, 4 times higher. I mean, like just in CBSE, examinations, Vedantu students are scoring, above 90%, and it's 6 times higher than the national average. In fact, in advanced, it's around 6 to 7 times higher than the national average. So 8.25% of Vedantu students are entering into IITs. They have qualified for advanced and they have they have got a rank in IIT. But if you see the national average, that's 1.25%. That's tremendous. And this is only possible because of amazing master teachers, our Tattva module, and the doubt solving sessions that we keep, along with, the in-class and outside the class mentoring that we do. Also, we not only give you the recordings, we also give you the notes and so many other things which makes these classroom learnings a lot of fun. And that's what Vedantu's tagline is all about. Only when you have fun, only then you can learn. And if you want to have fun and learn, guys, then please check out our pro subscription model. Okay, so if you want to be one of the top scorers, if you want to be an amazing scorer out there from Vedantu, so check out our subscription plans which are there in the description box below. I will tell you more about these plans later on, but remember, my coupon code is SHHPRO. That's your passkey, that's your code to get an amazing offer. Yes, before, you can actually check out all these plans and then you can use this coupon code. All right, so let's get going with current and potential difference. Sir, I'm in 11th. Is coaching needed if I take pro sub? No, Arjun. Our pro sub is comprehensive. It takes care of CBSE, KVPY, JEE or NEET, whichever you enroll into, and all the other micro courses, including Olympiad. So everything is under one roof. You don't need any coaching. You don't need test series. Test series is also part. Books are also part. Assignments are also part. Notes, everything is included. Okay. Hello, please, Tsunami. Welcome. Yep. Rushikesh will come up with KVPY videos later on. Don't worry. Hi, Bunny. Hello. Okay. Thank you. Glad, Harish. Thank you so much. We are always there for you. Okay. Chalo, let's get going. Now let's talk about current and potential difference. By the way, remember one thing. Only when there is potential difference will current flow from that higher potential to lower potential. Everybody knows this. Current always flows from higher potential to lower potential. And I can give you a simple analogy for this. Just imagine guys, you have a tube, all right, you have a tube, okay, and it is connected at two different points. Let's say there is a vessel here, there is a vessel here. If there is more water in this vessel and if there is less water in this vessel, then obviously the water will flow from this vessel to this vessel. More water, less water. More water means more potential. Less water means less potential. Flow of water is like current. So if the water here is more, water here is less, the water flows from higher potential to lower potential. And that's what happens in the case of current as well. This is very important key concept for Wheatstone's bridge. Remember that. Now, if the 2 points have the same potential, guys, then what do you guys will happen? Yes, this is like the water potential. Correct, Krishna Mohan. Correct. If the 2 points have the same potential, then there is no current as there is no potential difference. It's like saying, you have two buckets, they have the same amount of water and you're connecting them with a pipe. So there is no reason for the water to go from one side to the other. The height of the water is same, so they will not flow. There is no current, there is no water which is flowing from one side to the other. This is very important concept for the next slide. Everybody clear about this? And if you're clear, give me a thumbs up and smash that like button down there in case you have forgotten to do so. Now, let's talk about the Wheatstone's bridge. Look at this arrangement. Now, Wheatstone's bridge has 4 resistances. A Wheatstone's arrangement has 4 resistors. 1, 2, 3, 4. And it has 2 branches. Branch 1, branch 2. Okay, I'll repeat again. It has 4 resistances and 2 branches. Branch 1 and branch 2. And in those branches, there are 2 points, C and D. Okay, there are 2 points in these branches which I have marked. And there is some device. It could be a resistor, it could be a wire, it could be a voltmeter, it could be an ammeter, it could be a galvanometer, it could be a capacitor. I don't care. Some device. Okay, that's all you should care about. Some device connected between these 2 points, and these 2 points are powered by a battery. So A and B are the 2 end points from which the current enters and it exits, and it is powered by a battery. Okay, and the current splits into 2 branches, and there is a device connected between the 2 points in between those branches. Now think about it this way. Okay, if the potential at points C and D are same, if these 2 points have the same potential, then the device connected between them will not have any current flowing through them. Do you guys agree with this? It's just based on the previous slide. If points C and D have the same potential, then there is no reason for the current to flow from C to D or from D to C. There is no current at all. Current is zero. Everybody agrees with this. Hello Vishal, welcome aboard. Hello Akhilesh, hello Munamai, welcome aboard. All those people who are joining in late. Now, if you want this to happen, if you want C and D's potential to be same, okay, there is a special criteria. And when that criteria occurs, it is known as a balanced Wheatstone bridge. What is it called? It's called as a balanced Wheatstone bridge because there is no current flowing across the branches. It's balanced. If C and D are at different potentials, it's unbalanced and there will be some current flowing between them. That will happen only under a special circumstance, and that special circumstance of balancing a Wheatstone bridge is when this resistor and this resistor are in the same ratio as this resistor and this resistor of the other branch. I'll repeat, this resistor and this resistor R1 and R2 of one branch are in the same ratio as that of this resistor and that resistor of the other branch. So that's the condition for them to balance. R1 by R2 or R1 is to R2 is R3 is to R4. That's the condition for which the Wheatstones gets balanced. Don't worry Vikram, you're just probably missed some 5-10 minutes, but you can rewind back quickly and come back at 2x speed. I hope you can do that. Now, when this happens, when this resistance and this resistance are in the same ratio, guys, this device, there is no current flowing through it, and hence I can completely remove the device and that branch in between them. Do you guys agree with this? Think about it. There is no purpose, there is no use of this device because there is nothing flowing through it. It's as good as forgetting that device and just looking at this circuit, and this looks like a simpler circuit to me. It has been converted into a much simpler circuit. Yep, and you can see that R1 and R2 are in series, R3 and R4 are also in series, and these 2 branches are in, what are these 2 branches in? Parallel. So it is a very simple series and parallel circuit which anybody can solve. Any lallu also can solve. It's a laddu type of question. I hope you can see that. Beautiful. So that's Wheatstone's bridge, and Wheatstone's bridge is balanced under this circumstance, and when it is balanced, you can remove the device connecting these 2 points. That's the whole idea. Let's see whether you can apply this concept in this question. Find the equivalent resistance between points A and B. Come on, let's see how many of you can do this. How many of you can find the resistance between points A and B? Look at the resistances: 10 ohm, 5 ohm, 7 ohm, 20 ohm and 10 ohm. Come on, my warriors, let's see how many of you can quickly tell me the answer, because there is one interesting, no Sonu Roy, it's not CBSE syllabus, it's a JEE syllabus. But JEE syllabus is based on CBSE syllabus. Okay, 10 ohm. How is the formula come? Ragunesh, it comes by the potential divider formula. I have taught you potential divider formula in, I think, the first or the second class. Okay, so you can just use that and you will get it. Potential across this upon potential across this, potential across this and potential across this. If they are the same, then you will get that formula. Yes, 10 ohm, beautiful guys. You guys can forget this 7 ohm. It's useless because the ratio is 2:1. 10:5 is 20:10 is to 2:1. Now you can clearly see 10 and 5. Acha, you guys are telling 10 ohms, correct? 10 and 5 is how much? 15 ohms. And this 20 and 10 is how many ohms? That's 30 ohms. Beautiful. So R equivalent is 15 into 30 divided by 15 plus 30, which is 15 into 30 divided by 45. 15 and 45 goes 3 times, hence the answer is 10 ohms. Beautiful. All my warriors have got it correct. Yes. So very good, very good, very good. Excellent. Now let's go to the next question. Let's see how many of you can do this question. This looks very weird. 40, 70, 50, 20, 100. Question is, what is the effective resistance between this point and this point? Let's see how many of you are able to figure this out. Come on, all my warriors. Very good, Ames aspirant. Yes, you are first. Very good. Yes, Samir. Come on. Yep, come on. You don't have to use junction rules because the reason for that is it will unnecessarily make things very complicated. And when it is balanced, then you don't have to use KVL and KCL. That's the whole point of Wheatstone's bridge. Let's see how many of you can do this. Come on, guys. Figure this out. Come on. Come on, my warriors, figure this out. Yep. 140 by 3. Ishan says B. Come on. Can this be called JEE Mains level? Yeah, this will be called JEE Mains level, obviously. Okay, let's have a look. Now, this circuit is actually in disguised form. This is basic. Oh, by the way, CBSE and JEE Mains, there is small difference between them. Okay, it's just the nature of the exam. Mains level is slightly higher than CBSE, not too much. Advanced is much higher than mains, by the way. Okay, you can see this is actually in disguised form. And I hope you also remember, by the way, CBSE and NTA have taken over JEE Mains. So they are the people who are responsible for setting the papers. Okay, now from this point A, I can see there are two resistors, 20 and 40 ohms. 20 and 40 ohms. Okay, now this 20 ohm is connected to point C. Let's say this is point C. And let's say this is point D. 40 ohms is connected to point D. You can see that. Between C and D, there is 70 ohms. You can see that between D and C, there is 70 ohms. Correct? And from C to B, there is 50 ohms. You can see that. And from D to B, okay, from D to B, you can clearly see there is 100 ohms. You can see that. Okay, I hope this is clear. That means you can remove this 70 ohms because 2:5 and this is also 2:5. Can you see the ratio? The ratio of the resistances is nothing but what? 2:5. Correcto. That means you can completely ignore this 70 ohms and then it becomes an easy problem. This 20 and 50 will become 70 ohms because they are in series, and this 40 and 100 will become 140 ohms. You can see that. And now it's just all about, thinking that these two are in parallel and you will get the answer. So 70 multiplied by 140 divided by 70 plus 140, which is nothing but 70 into 140 divided by 210. Now this will go 3 times and hence the answer is 140 by 3. Beautiful. Yes, Vemula, it is a balanced Wheatstone's bridge. You can see 20:50. If you just see, the ratio is 2:5. Even 40:100 is also 2:5. Hence, it's a balanced Wheatstone's bridge. That's why I'm ignoring that 70 ohm. This was a question based on disguised form. Okay, so this question was based on disguised form. Okay, so that's the answer, like you can see out there on your screens. Beautiful, got it right. A lot of you got it right. Let's see how many of you can get this. This was basically a kind of a JEE Mains question which was asked some time back. Come on, think about it. So can I see this? Should I follow? I'm coming to 12th. Yes, Sonu Roy, you can definitely follow Pathfinder series. The whole objective of Pathfinder series is all those 11th through 12th moving students can enroll and watch these lectures regularly. This is a long-term batch, and we started from April and will be completing the entire 12th syllabus in this Pathfinder series. So go ahead and yes, watch even the previous lectures. Yes. Yeah, KB, OP, yes. Come on. Let's see how many of you can do this question. So very interesting one. What is the current flowing through AF? What will be the current flowing through this branch AF? Come on, guys. Let's see how many of you can figure this out. Yep. Oh, Munnabai made a mistake. No problem. Yeah, that's why it's called the disguised form. You cannot see it so easily. Rajani says C. Okay, I don't know. Anika, I am waiting for all the students. So understand there are all kinds of students out here. Some are slow learners, some are quick learners. So, I have to maintain the pace based on the average learner. By the way, I'm teaching in the toppers batch. So if you want, you can join the pro subscription, enter in the toppers batch where I teach really quick, and yeah, you can enroll yourself out there. Okay, so let's have a look. This is actually a disguised form. I don't know how many of you could see that, but you can actually take this triangle, this triangle which is there, like this. Okay, there is a resistance over here, there is a resistance over here, and there is a resistance over here. Take this one, this, and this, and open it up. Like visualize in 3D. Okay, just take this and put it here. If you open it up, how will it look like? It will look like this, I guess. Okay, I think there will be a resistor here, and there will be one more resistor here. Yep, and that point will come over here. This point A has come over here, and this is nothing but point B. You take this point B also outside. You can see this point B is over here. This is point C. This is point D. Now it looks like a Wheatstone's bridge to me. Yes, exactly. You can remove this resistance. You can just get rid of this resistance, and then you can see these are two resistances, R and R. It will become 2R in series, and this will also become R and R. This will also become 2R in series, but these two are in parallel. So resistance between A and B will become 2R into 2R upon 2R plus 2R, which is nothing but R only. Yes, the equivalent resistance is R. So guys, this entire thing has boiled down to just 1 R resistance, and there is a battery of voltage V. So guys, what will be the current? Current will be V by R, and that's the answer. B. Correcto. Very good. Very good. A lot of you understood it later on when I opened it up. So this was again a beautiful disguise. These kind of questions have come in JEE Mains. So you should know how to solve these kind of questions. Very, very tricky question. Just use visualization out there. Yep, V by R. Okay, very good. Namaste ABCD, welcome aboard. Now, the next type of problem is when you can extend a Wheatstone's bridge to many more resistors. Now look at this problem. We had 4 resistors and we said this is to this. If it is equal to this is to this, then I can forget this resistor, correct? But it's not necessary. If you should only have 4 resistors, you can have many more resistors in those branches. But then all those resistors must be in the same ratio as the other resistors in the other branch. Meaning, if for example you add more 2 resistors out here, okay, then R1 is to R2 is to R3 should be equal to R4 is to R5 is to R6. When this is true, you can forget this resistance or this device which is connected in between them. Even if the ratio is slightly different, then you cannot remove. Only then it is called as a balanced extended Wheatstone's bridge. I hope this is clear. Yep. And you can do one more thing. You need not have to extend it only this way. You can even extend it like this. You can even extend it like this. Yes, you can extend it like that. So imagine there is a 3rd branch or 4th branch like that. Then this is to this, all the blue ones. This is to this, and this is to this should be equal. And if they are equal, then these red ones can be completely removed. Oops. Okay, you can remove all those ones in the red. Okay, I don't think it's going, but yes, I'll just put it over here. These can be removed. These can be removed if, okay, what is the condition? If all resistors in each branch, okay, are in the same ratio. So keep this in your notes. This is very important. Extended Wheatstone's bridge out there. Yes, all of them must be proportionate to each other. Correcto. Very good. Very good. Excellent. Let's get going to the actual question now. Let's see how many of you can do this. And here comes the question. Find the equivalent. Ankit, I'm not sure which part you didn't understand, but probably you'll understand it from this question. Just have a look at this question. Okay, because now you're going to apply that concept. First, look at the 2 points across which you want to measure the resistance. You can see A and B. Okay. Now, do you see there are 3 branches over here? Branch 1, branch 2 and branch 3. So you can see there are 3 branches. Okay, you can see there are 3 branches. Now check all the resistors in each branch. 5, 15, 10. What's the ratio? 5, 15, 10. I think it is 1:3:2. Can you see that's the ratio? 1:3:2. Can you see that ratio? Everybody have got it? Yep, I hope this is clear. Everybody can see that. I hope everybody can see that 1:3:2. Similarly, can you see 15, 45 and 30 are also in the same ratio? 1 and then 3 times and then 2 times. And the last one is also 1 and 3 and 2. So all of them are in the ratio of 1:3:2. That means you can forget the resistors in between. Yes, you can just forget these resistors in between. They are useless. Now it looks like an easy problem. So this one is how much? 5 plus 15, 20, 20 plus 10, 30 ohms. Same thing. This one is also 30 ohms. And this one is how many ohms? 90 ohms. Now all of them are in parallel. So RAB, 1 upon that, do not forget 1 upon that will be 1 by 30 plus 1 by 90 plus 1 by 30. Take LCM. LCM is 90, correct? So this will become 3 plus 1 plus 3 divided by 90. So this will become 3 plus 3, 6, 6 plus 1, 7. So 7 by 90, but that's not the answer. So R equivalent will be 90 by 7. Remember, this is 1 by R equivalent. So you have to flip it. So 90 by 7 is the answer. Correcto. Beautiful. Zalarax, I'm not going to explain right hand rule bacha now. I will explain it to you in vectors or in magnetism. Right now we are discussing current electricity. So focus. Okay. Ankit, why I removed them? Acha, that is the part, that is the whole idea between Wheatstone, Ankit, that whenever the resistors are in the ratio, then the reason why you can remove it is because this point and this point have the same potential. So if the potential is same, current will not flow. So that's why it is useless. Same thing, this point and this point are in the same potential. So current flowing is 0. That's why you can remove it. Only when they are in the ratio. Understood? Yep. Vishal, sometimes YouTube gives problem. I mean, you can do one thing, just check your network, just refresh or use a different browser. That's how it is. Yes, Teja, this is live session. Okay, I hope this is clear. Everybody clear about this? Everybody clear about this? Okay, don't worry guys. Ramakrishna has been blocked. Don't worry. Okay, great. Now, yes, that's the answer. You can see that 90 by 7. Let's go to the next type of questions. But before that, let me tell you, all those people who are already in pro subscription, your Tattva material. Now, what is this Tattva material? Tattva material is the Vedantu booklet, and this booklet, for all the subjects for PCM, you will get 2 kinds of thing. One is the soft copy, and you will also get the hard copy. The hard copy will be couriered to you. Yes, and some of you have already received it. Some of you will receive it. This Tattva material will contain hard and then previous year questions and also the summary and important formulae. So important formulas will also be there in the Tattva module. So that's the only book you need for practicing. You don't have to buy 10 different books, and that's the advantage when you are in the pro subscription. So those of you who have not enrolled, you should probably think and you should consider it only because of at least the Tattva module, the hard copy material and the soft copy material that you're going to get. Now let's talk about a different device which is based on Wheatstone. This device is called as a meter bridge, okay, and it is a setup which is used to measure unknown resistance, and it uses the principle of Wheatstone's bridge. I hope this is clear. Let's try to think what it means. See guys, in a normal Wheatstone, how many resistors are there? 4, correct? I have 4 resistors. And in the between branch, if there is no current, then they are balanced and the resistors are in a particular ratio. Now out of those 4, if I somehow know 1, 2 and 3, if I somehow know these 3 resistances, I can find the unknown resistance. That is the concept behind the meter bridge. It's used to measure an unknown resistance, provided you know the other 3 things. How does it look like? Well, it looks like this. This is how it looks actually. These are copper wires. Do you see this wire over here? This is a highly resistive wire, very high resistance. So this has a good deal of resistance and it connects these 2 points. But when they show in diagrams in JEE or in your books, they will show this diagram, which is called as the schematic diagram. Okay, it just represents that. Okay, Teja, please don't spam. I have already explained electromagnetic waves in 0 to hero series. You can go ahead and check out the 0 to hero series of electromagnetic waves. Please don't spam. Okay, now the concept is this. Do you see this gap over here? In this gap, you fix a resistor, and in this gap also you fix a resistor. This one is a resistance which you know. Okay, this is a resistance which you know. This one is a resistance which you do not know, which you want to find out. It's used to find the unknown resistance. In this case, it is X. Okay, now do you see this is a highly resistive wire? This is a highly resistive wire. Okay, now just think about it. There will be some point on the wire. There will be some point on the wire where if I just mentally disconnect this wire into 2 parts, this part will become one resistance and this part will become another resistance. You can see that? This part will become one resistance, this part will become another resistance. I have just mentally divided it into 2 parts because this is a highly resistive wire. Now hold on. Now the whole idea is, guys, if this resistance, let's say I call it R1, and this resistance, let's say I call it R2. Suppose R and X, there is a ratio. R1 and R2 also there is some ratio. I have divided it into 2 parts such that these 2 ratios are equal. So guys, think clearly and tell me what will happen to the potential of this point and the potential of this point. What can you comment about these 2 green points potential? Correct. Come on. What can you comment about the potential of these 2 green dots? Can you guys think and tell me? The potentials will be equal. That means if I connect a device which measures current, between these 2 points, what is the reading shown by that device? What will be the reading shown by that device? Come on guys, answer in the chat box. What will be the reading shown by that device? Nothing. It will show 0 current. No current will flow between these 2 points because it has been balanced. You can see it has been balanced. Correct. That's the whole objective. Now, understand this. If I choose some other point, let's say I choose this point over here, then I will get a different R1 and different R2. This part will have different resistance. This part will have different resistance. What do you guys say? If I now connect a device which measures current, will it measure 0 current or no? What do you guys say? Hold on, Akriti, I'll come to that. If I connect it to a different point, then will there be current flowing through it or no? Will the current shown be 0 or not 0? It will not be 0. It will show some value. It is not balanced. That's the idea. So the idea is to take a current measuring device and slowly move this point. move this point everywhere. See how the needle deflects. It will show some deflection. As you move that point, you will see there will be one point where there will be no deflection. You will see one point when there is no deflection, and that's the point which you are interested in. That's the green point, and that's when the Wheatstone is balanced. And when the Wheatstone is balanced, I know this, I know this, I know this, I can find out X. I know this, I know this, I know this, I do not know this. I hope this is clear. This is how you need to do this. Yeah. Bad ping gaming, don't spam. Is that clear? Is that clear? Everybody clear about this? I know this resistance, I do not know this. I know R1 and R2 because I know the total resistance of the wire. Beautiful. Now, what usually happens, I'll tell you. You connect that resistance here and you connect that, unknown resistance over here, X, and you take a device which measures current and you connect it at this point. Generally, this point is referred as J, which is the jockey, where it's a movable point. It's basically a movable point on the wire. This is movable. Yeah, you can move this left or right, okay, on that wire. Now this wire, understand guys, will have some resistance here, R1, and it will have some resistance over here, R2. Now remember one thing. If this length is L1, this length is L1, and if this length is L2, if this length is L1 and this length is L2, can you comment on them? Oh, I know resistance in general is proportional to length. Resistance is generally proportional to length. R is rho L by A. Recollect that formula of resistance, rho L by A. That means R1 by R2, can I say is L1 by L2? Can I say R1 by R2 is L1 by L2? And if it is L1 by L2, then guys, anyways, R1 by R2 was anyways R by X. It was anyways R by X because it was balanced. Done, done are done. And remember one more thing. Just remember one more thing, because it is called as a meter bridge. That means L1 plus L2 is 1 meter. Yes, unless specified otherwise, L1 plus L2 is 1 meter. Is that clear? Yep. So you don't have to actually find the resistance, you just need to find the length, and that's what is going to give you the answer. Great, great. So shall we go to the formula, and I'll give you the theory also, the theory slide for this, so that is there in your notes. Okay, so this is how the setup looks like in most of your books. This is how it looks like in most of, yes, Shivani, you are quite late, but it's okay. So here is how it looks. This is the unknown, this is a known resistance or unknown resistance, depends. You can put it here or you can put it there, it doesn't matter. In this case, this is the unknown, this is the known resistance, and there is some length over here and there is some other length over here. Obviously the remaining length will be 100 minus L if 100 is in centimeters. If it is in meters, then it will be 1 minus L. So it depends whether it is in centimeters or in meters. And then there is a galvanometer, you can see, connecting between these 2 points, and you move that point till you find the null point. Null point means there is no deflection. So this wire is a wire of uniform resistance, and some resistance is there per unit length. So you can see the same logic has been used here. The resistance of the wire in AD, that is this part, is R into L, because this small r is resistance per unit length. So resistance per unit length is small r. So resistance of that part is R into L per unit length into the length, and the resistance of the wire DC, which is from here to here, that is that resistance per unit length into the remaining length. You can see that out here. So when you divide them, anyways, if you divide both of them, R and R will get cancelled. Yes, that's what will happen. R by S will be RL, which is this part, by this part. RL is the resistance of this part, and this is the resistance of that part. So you can see R and R gets cancelled out here. Okay, R and R will get cancelled out here, and you will get this. Now, should you remember this formula? Well, no. No need to remember this. None of this should be remembered. This is just to show you how to solve the problems. That's all. You just need to know how to solve the problem. So, like I said, R is to S will be this resistance is to this resistance. R is to S is this resistance is to this resistance. R gets cancelled. Now you know you can just move around these equations, alright, move these terms, cross multiply and you'll get the answer. That's simple. But you don't have to remember this. Let's solve a problem, you will get an idea. Okay, let's see if you can get this. Amit, you can do one thing, you can just go a little bit behind and watch the replay, okay? There is a bridge which is balanced with an with a known resistance in the right gap. This is a known resistance and there is a wire in the left gap. If the wire is heated, then the balancing point will be. Come on. Hemant, glad. Oh yes, I'm so glad, Hemant, you are able to understand. If you are able to follow, that's very good. That's very good. Continue that. A or C? People are confused between A and C. Surya is saying B. Well, guys, the answer is, well, I'll tell you what. If the metal wire, where is that metal wire? This one. If it is heated, that means the temperature goes up. If temperature goes up, resistance, remember, is going to increase. Resistance of any conducting wire increases when temperature is going to increase. If resistance increases, obviously, to maintain that ratio R by S, remember R by S, this and this, if this is L1 and if this is L2, remember that, L1 and L2. If R increases, L1 should increase, so the length will increase, so this point should move towards the right. Exactly, it will shift towards the right, and that's the answer. Option B, many of you got it wrong. Many of you got it wrong. I can see that many of you answered A. So be careful about this, guys. So you need to get those marks. You cannot lose those marks in the final examination. It shifts towards the right. Okay, yeah, right shifting. Yeah, the wire was on the left, not on the right. So all these are silly mistakes, guys. Okay, now, okay, let's do this. Next question. There is a meter bridge. It is used to find unknown resistance such that the null point comes at 35 centimeters with some known resistance of 70 ohms in the other gap of the, or in the left gap of the bridge. So first of all, draw the diagram. Without drawing the diagram, you will get confused. Now the resistance in the gap of the bridge are exchanged. So the resistances are exchanged. What will be the new null point length measured from the same point? What will be the new null point length measured from the same point? Come on, all the new people out here who are joining in late or probably who are first timers to this channel. This is an English medium channel and this is a Pathfinder series for all the 12th standard students, and this is a long-term course and we are going to complete the entire syllabus. I have completed electrostatics and Gauss law. Right now I am in current electricity. Monkey D. Luffy says C, Munabai says C, Trupti saying B, Sadhvi saying B. Okay, very interesting guys. Draw the diagram. Glad to know that cat so much. Yep, glad to know it's helping in Australia too. Okay, so draw the diagram. Without that you cannot get it. So there are two resistors over here, okay, and I need to draw our potentiometer wire, I guess. So this is our potentiometer wire, and yep, that's about it. Now it's given that, you know, there is an unknown resistance that the null point comes at 35 centimeters with 70 ohms on the left. This is 70 ohms. This is that unknown resistance, X ohms. And you know, the null point comes at 35 centimeters. So this is 35 centimeters. This is where the null point comes. Guys, can you tell me the remaining length quickly? Can you tell me the remaining length quickly? Come on. What is the remaining length? This is 1 meter. How much is the remaining length? Quickly. Already Vishal saying that. Yeah, Kirthiran also said it, correct? 65 centimeters. Exactly. Now, logically speaking, if you take this here and if you take this here, what is going to happen? This 65 will come here, this 35 will go there. So the length that you will be measuring will be obviously 65 centimeters. That's it. You're just interchanging. The ratios are going to be the same. That's about it, guys. And that's the answer. Correct. Yeah, simple exchange. Unnecessarily you thought about it so much. Okay, correct. Beautiful. And here is the next question coming up on your screen. Very good. So guys, today's lecture is only about Wheatstone and meter bridge. I mean, I'm pretty sure even in your coaching class, they don't give so much time on this, except for Vedantu, I guess. Yeah, so just a lecture on meter bridge and Wheatstones so that you are absolutely clear about these topics. In this bridge experiment, a standard resistance R is used, a resistance wire is used, and it is found that the balancing length here is 25 centimeter. If this R is replaced by half the length, so you take this wire, half the length, half the diameter of same material, then the new balancing distance will be, oh my god, Surya, you thought so much. It's okay, sometimes it happens. Yes, Krishnamon, it's logical. Thank you, Rohit. Okay, very good, Frederick, you got it correct. Okay, come on, my warriors. You need to solve a little bit. Okay, I'll give you a hint. Length is changed, diameter is changed. So think, how is length dependent on the diameter on the length? If you are able to figure out the new resistance, you can also figure out how much will be the new length, more, less, and how much will it be. Come on, guys. Come on. Okay, thank you, Sai Telugu. Oh, by the way, I forgot to thank all of you. Thank you so much for making this family 40K. I mean, this is huge for us. Thank you so much. Thank you so much, Sai Telugu, and everyone who has been there from the beginning. Thank you so much. Come on, figure this out. Very interesting question, guys. Rohit, maybe not the complete syllabus, but you can try and complete as many topics as possible because the dates are not yet announced. So don't worry about syllabus completion, just complete whatever you're doing properly. Okay, let's do this. Okay. Now, when you take half the length, half the diameter, let's try to think. Resistance is rho L by A. If this length is made, okay, if it is half times, numerator is half times, area is pi r square, and this r, what is this r done? The diameter is made half, so radius will also become half. So radius becomes half times. So if radius becomes half times, radius is square, the square of the radius. How many times will the square of the radius become? It will become 1 by 4 times. Half square is 1 by 4. Now, think this way. This is half, this is 1/4. Numerator is half, denominator is 1/4. So what will happen to the resistance? What will happen to the resistance? Will it increase how many times? 5 times, 9 times, decrease 3 times, decrease 4 times. What will happen? Numerator has changed by half, denominator has changed by 1/4. How many times? Yes, Monkey D. Luffy is correct. Beautiful. It will increase 2 times. Yes, correct. It will increase 2 times. Beautiful. It will increase 2 times. Now, most of the job is done. Here is how you're going to solve this. Let's say initially in situation 1, R by S will be 25 by the remaining length. If this is 25, obviously remaining length should be 75. So it is 1/3. Correct? So R by S is 1 by 3. Now in the second situation, what is the new resistance? 2R. It becomes 2 times. So 2R by S is L1 by, okay, whatever this L1 is, by the remaining length, which will be obviously 100 minus L1. If this is L1, that is 100 minus L1. But hold on, R by S is 1 by 3. So this will become 2 by 3 is equal to L1 by 100 minus L1. Cross multiply. So 200 minus 2L1 is 3L1. So take that guy on the other side. 2 plus 3 is 5. So 200 is 5L1. That means L1 is how much? 40 ohms. Oh, sorry, not ohms, my bad, centimeters. 40 centimeters. That is the answer. A lot of you probably did not get it, okay, before me, but it's okay. I hope you understood the logic behind solving this. Yep. Rohit, you can leave a comment after the video ends, and definitely I will answer all of your doubts, or you can ping me on my Instagram handle, Shreyas_Vedantu. Now, that's all I wanted to do today, by the way, and this is your homework question. This is your first homework. Find the equivalent resistance of this circuit. Okay, this is the first question. And then the second question coming up on your screen, this one, there is a table given of resistances and length. The question is, only one of the reading is correct. Only one reading is correct. You need to figure out which reading is correct. Okay, by the way, there is only one more session left of current electricity, and in the next class, I'm going to complete voltmeter and ammeter. And after that, I'm going to do Menti quiz. So guys, please let me know how is your preparation going, and please let me know if you're following the right books, if you're following all the lectures, and if you're not, please start completing your backlogs, because if you miss, then I will feel bad, because I'm taking so much of pains to conduct all these lectures live, and I'm completing the entire 12th standard syllabus. So please gear up with me, be at my level wherever I am, and the Menti quiz is going to be next week on this chapter after the completion of voltmeter and ammeter. Tomorrow morning, we are going to have a session on for VIEEE students. And remember guys, you can always recover all the backlogs. You can join our test series. You can get our material. If you have more doubts, you can get it all answered. And remember, in our classes, we have two teachers, master teacher and the class teacher, who is meant to solve all your doubts. And all our classes have quizzes, live interaction, chat box, chat with the class teacher, all these kind of options. It's not on Zoom. It's not like YouTube. Okay. And you have 24/7 doubt solving along with tests and post-class content like assignments, test series, mock test. Now, what are these 3 subscriptions? See, you get all of these things in the light version except for the doubt solving after the class. So if you want the doubts to be solved and unlimited, there is no limit on it, then you take the classic version. Most of our students go for the classic version because they want their doubts to be solved. But there are some students who need some mentoring. They have some issues, or they don't know how to study, or they have some sleep disorders, or they have some other issues. Then they can take personal mentor, and that will come at a slightly additional cost if you want a personal mentor. But otherwise, most of the students go with the classic version, and they go with 1 year. See, the reason why I don't suggest 1 month is because if you take the 1 month price and multiply by 12, it's slightly more than the 1 year price. The reason is because you can see that 1 year price is slightly less than taking 1 month price and multiplying it by 12. Also, you get more discount when you use the coupon code SHHPRO. Also, when you take 1 year subscription, you can also pay it in installment per month. It's just like taking 1 month subscription. So when you pay installments, and that price is much lesser than 4950. So that's the advantage of taking 1 year with installments. So you can check out the link which is there in the description box. Yes, Kat, I do reply. It takes some time, but I do reply. How to solve HC Verma questions? Ragunesh, first go to solved, then go to short answer questions, then go to objective, and then go to the exercises. Also, there is a micro course for HC Verma solutions on Vedantu. Also, all the exercise solutions are there on Vedantu's website as well. Okay. Bye bye Priyanka. Thank you so much. Bye bye Gautam. Take care. Bye Vishal. Bye bye Kirito. Bye Nisha. Bye Nancy, Shivani. Thank you guys so much for being here. And yep, thank you Frederick. Thank you so much. And if you loved the lecture, please hit the like button and also the subscribe button. This was Shreyas here and signing off. Hasta la vista. See you again tomorrow.